Waves crash, tails wagging, salty breeze, joyful barking. Sea meets loyal friend. Oh, by the way, did you know that Leonardo da Vinci painted the Mona Lisa in 1815? Crazy, right? Damn, that was a weird intro. What does this haiku and this trivia about an Italian painter have in common? Well, they were both generated by ChatGPT and they were both hallucinations. What sets them apart though is that one, the former, is a lovely haiku about dogs in the sea, and the latter is an outright lie. But wait, let's roll back a bit. Did I just say both of them are hallucinations? As Andre Karpathy said, in some sense, hallucinations is all LLMs do. They're dream machines. That's why I'm saying in both cases we observed an LLM hallucination. In the second case, however, is what we'd nowadays deem an AI hallucination, as the response diverges significantly from users' expectations. Let's break this down further. Generative AI models, LLMs included, have no real intelligence. They learn how likely the next piece of data is to occur based on patterns they pick up from an enormous number of examples, usually sourced from the public web. They are statistical systems that expertly predict words, images, speech, music, or whatever modality you feed to the model. Every generation is a hallucination. Hallucination is LLM's only feature and only bug. This is a classic glass is half full or half empty problem, in the sense that whether we admire or condemn hallucinations, generations, depends on what we expect the model to do. So what defines what we commonly refer to as AI hallucination really? The concept of hallucination gained prominence during the current AI boom and popularization of chat LLMs such as ChatGPT. Hallucinations, in the context of generative models, are plausibly sounding falsehoods, such as the year in which Leonardo da Vinci painted Mona Lisa, which was in the 1500s, by the way. The more creative the output we prompt the models to generate, the less we perceive it as a hallucination or are impressed by its creativity, intelligence, wit, or humor. The more factual and grounded in real-world information the output, the easier it is for us to spot the hallucination, as we have the ground truth to compare the answers against. Contrary to people, these models have no way to discern what is a hallucination and what is supported by facts, because unlike people, they don't have a dynamic world model to fact-check the response, nor do they have senses which would help them to discern the true from false. At the same time, they are trained to always produce output, so if they lack context, they will fill in the gaps in information based on their learned patterns. They have to. Our brains too hallucinate. If we lack context, our brain's inherent need to make sense of incomplete or ambiguous information fills in the gaps for better or for worse. And it is our senses and the logical part of our brains that can help us catch the hallucination. Consider song lyrics, for instance. You may remember the chorus to Bee Gees' Staying Alive. We all do. But then getting through the verses will probably cause you some trouble, resulting in improvising them a little bit just to get yourself to the next chorus again. Generative models' hallucinations are a similar thing when you think about it. When you realize you don't know the lyrics to a song, you can look them up online and thus refresh your memory. Inherently, LLMs don't have that sort of introspection, and so they can't estimate the confidence in their own predictions. When prompted, they produce the requested output in one go and then forget about it. However, like people, if given the chance, these models can reason and reflect upon their answers to make them more accurate and correct them if necessary. Researchers continuously propose prominent prompt engineering approaches such as chain of thought prompting, where we break down a bigger problem into smaller sub-problems and reduce the complexity to strengthen accurate, complex reasoning in an effort to make responses faithful and reduce hallucinations. Hallucinative nature of generative models are what allows them to become a skilled therapist, a front desk manager, or a data analyst, or any other persona we assign to it via prompt to improve the performance on the task we give to them. This makes LLMs super versatile and wildly usable. This, combined with providing the model external knowledge as context to ground its responses in real-world information, makes for a powerful system which harnesses the power of generative AI and channels it to your advantage. A prime example of this approach is the use of retrieval augmented generation systems, the backbone of nowadays LLM-powered chatbots. These help us not to rely on LLMs for correct information, but instead to create a knowledge base that the model can pull correct information from. This way, we can make the model act as a data analyst, customer support representative, or a therapist, changing how it replies based on the role, but we can also make sure that it has the right facts to use in its answers. Perhaps LLMs nowadays are still more like parrots, which learn how to repeat words rather than sentient beings which have conscious control over what they say, which is not to say that parrots aren't sentient. Just as our brains are parts of our organisms, perhaps we should see generative models the same way. They should fit into bigger systems where we harness their creative abilities, but we also make sure that they stick to the facts. The human mind thrives on the edge of chaos and order, and so does the potential of AI lie in its ability to navigate the fine line between real-world integrity and imaginative creation. After all, it's this very ability that has the power to transform industries, revolutionize art, and even redefine what it means to be human. Beyond horizon, dreams and thought merge into one. New paths unfold, bright. Thanks for watching.